Hi, and welcome back. We're going to talk about our third measure of central tendency, the mean. It won't take us nearly as long as the median because you've been calculating means for most of your life. The mean is the sum of the values in the data set divided by the number of values in the data set. Using our summation notation, this is saying add up all of the x values. This is the number of values in the data set. So this is a simple function. You've been doing it for a while. Please don't call it an average until May or later. For now, this is one type of average called the mean. If we take the variable of interest and put a bar over it, x bar, that is one way to represent a mean. Some books will also use a capital M for mean, and many will subscript that M with a variable name. So M of x would be the mean of x, M sub y would be the mean of y, etc. If we were calculating the mean of y, this would be y bar, this would be the sum of y divided by n, etc. Mean's easy to do. You've been doing it for a while. How you think about the mean's a little more complicated. Let's talk about what statisticians use to think about the mean, and that is this. The mean minimizes the signed deviations about it. So the mean is the constant that makes it so that the sum of the deviations between that constant and every other value in the data set, that is the difference between those, is minimized. Not only is it minimized, but it always comes out to the same thing, 0. Another way of saying this is we're going to go through each value of the data set and subtract the mean from it. And that's going to be a single deviation from the mean. We will keep track of sign. We'll do this for every value in the data set, then add those together. This is our sum of the signed deviations about the mean. It will always be 0. Just come up with any 5 numbers you want, anything from 1,000,002,000 to -77. Add them up, divide by how many there are, and then go back and calculate the sum of the deviations about that mean, and you will get 0. This is an important thing to know, and it will come back up in the course. As you maybe have read, and it is certainly true, the mean is very sensitive to outliers. Here are 3 data sets, an x, a y, and a z. They are identical to each other except for one number. The mean ranges from 6 to 116 here. X and y and z have a lot of values in common. This one outlier causes the mean to jump from 6 to 16 to 116. So if you're dealing with very skewed distributions and your job is to describe a data set versus trying to think about how to draw inferences from a sample to a population, many people will prefer the median for just this reason. The mean number of DWI arrests, the mean number of children, the mean amount of money made in the United States of America. These are all things that are sensitive to outliers and measures where the median might be more descriptive and helpful for your reader. The mean can be used with ratio and interval data. For the mean to work, the differences on the scale of interest need to be consistent with each other. It won't work with purely ordinal data. As you've heard, the mean is sensitive to outliers and more sensitive to outliers than the median. It's a little bit harder for a lot of us to think about what it's representing. It's certainly very easy to think about what the median and the mode represent. And the mean is very, very useful for inferential statistics, which we'll be discussing much later in our course together. So that's it for the mean. Going to close down for now. We have one more mini lecture in this section where we'll work some problems and compare calculating the mode and the median and the mean. Thanks for listening and watching.